All right, so here we're going to look at this question, and the question is the vapor density of methane CH4 is A4, B8, C16, D32, and we're given the relative atomic mass of carbon to be 12 and the relative atomic mass of hydrogen to be 1. All right, so the first thing I would want to do is to first of all write the relationship between vapor density and relative molecular mass. All right, so the question again is the vapor density of methane CH4 is, so you should know that relative molecular mass of a compound is equal to what? 2 times the vapor density of that compound. All right, you should know this relationship, that relative molecular mass is equal to 2 times vapor density. So what is the relative molecular mass of methane? Because what we're asked to look for in this question is to look for the vapor density of what? Of methane. So what is the relative molecular mass of methane? So the relative molecular mass of methane CH4 is equal to C plus H4. The relative molecular mass of a compound is the sum of the relative atomic masses of the elements in that compound. So this relative molecular mass of methane is the sum of the relative atomic mass of carbon and hydrogen in that methane. All right, so the relative molecular mass will be equal to the relative atomic mass of carbon is what? Is 12. So that's 12 plus the relative atomic mass of hydrogen is what? 1. 1 times 4 atoms of hydrogen will give us what? 4. So this will be equal to 4 plus 12, or 12 plus 4, that will give us 16. So the relative molecular mass of methane is equal to 16. All right. So now that we've gotten the relative molecular mass, what will be the vapor density? So again, the relationship between relative molecular mass and vapor density is relative molecular mass is equal to 2 times vapor density. So now we've gotten the relative molecular mass of methane to be what? 16. We've gotten it to be 16. So this is 16 is equal to 2 times the vapor density. All right, so this will be 16 is equal to 2 times Vd will give us what? 2 Vd. All right, so in other words, 2 Vd is equal to what? 16. What I have here and what I have here are the same. 16 is equal to 2 Vd. 2 Vd is equal to 16. They are the same. All right, so to make this Vd stand alone, I will divide both sides of the equation by the coefficient of what? Of Vd, which is 2. So this will be divided by 2, divided by what? 2. So that this 2 will cancel out this 2. So my Vd will be equal to 16 divided by 2, and that will give us what? 8. So the vapor density of methane is what? 8. So that makes option B to be the correct answer. All right, it's a very simple and a straightforward question. So you should know the relationship between relative molecular mass and vapor density, and the relationship is relative molecular mass is equal to 2 times vapor density. This relationship is very important. All right.